All right, y'all. Last big trig lecture. Then we're doing polar stuff later. All right. I usually don't. All right. Let's do this beast. You guys post this for my YouTube channel? All right. Don't. All right. 197. Don't get in the video. Get out. Yeah, students aren't allowed to be in here. All right. This has been a great video. I should start. All right. Uh-oh. Okay. So look at this beast. We have sine of A is 4 over 5, and it's in quadrant number 2, right? Which one's quadrant 2? Is this one? This one? Yeah. So I'm going to draw it in. I'm going to draw in a triangle, right? And I'm going to call this one angle alpha. And what's 4 then? That's 4. That's 5, right? Does anyone disagree with what I just did? Okay. So then I'm going to draw angle B. Angle B is in quadrant 1. And it would be angle beta. And sine is 1 over 2. So it's 1 over 2. Anyone disagree with anything I've done so far? All right. All right. So then, this will feel good. What's cosine of A? That's adjacent over hypotenuse, right? What's my adjacent to angle alpha? How do I find that? Pythagorean theorem, right? I got 3. Do you guys agree or just? So my adjacent is 3, my hypotenuse is 5. Anything too scary with that? Or does that feel like a good review from a long time ago? Oh, wait. I was just going to say, is that right? Why is it negative? Which quadrant are we in? Yeah, I went left, right? So I could make that -3. Just know that in quadrant 2, cosine is negative. Sine is positive. So now what's cosine of B? How am I going to find this missing side over here? Yeah. Pythagorean theorem. Square root 3. 4 minus 1 is 3. Never mind. I was going to say there's not. Yeah. So what's cosine of B going to be then? My adjacent or hypotenuse. So root 3 over 2. And that one is positive. So we're done. Okay. So now think about this. I know what cosine of alpha is. I know what sine of alpha is. I know what cosine of beta is. I know what sine of beta is. Can I find cosine of alpha plus beta? Let's see if I can do this from memories. I won't even look at the book. So for cosine, it's cos. Do I keep the sign or flip the sign? Flip the sign. And then sine, right? So it'd be cosine of alpha, cosine of beta, sine of alpha, sine of beta, right? What is cosine of alpha? -3/5. What's cosine of beta? Root 3 over 2. Sine of alpha was 4/5. And sine of beta was 1/2. Yarnar. What's -3? I have to write up here. I ran out of room. So if I want to simplify this, I would get what? -3 root 3 minus 4, right? -4 all over. Do I have a common denominator? 10. No calculator required. That is right. Wait, let me check it, actually. Oh. No, this is something. old pre-calc before AP, this you'd spend a whole marking period on like the double angle and this formula and stuff. It doesn't come up as much in AP though, which is I'm okay with. It does come up a lot in calc. This one? Oh, it was right here.
How did you get it to put it that way?
How did I know to do that? Page 144. They're your angle sum identities. I haven't seen one yet, but it could be. Usually if it's on the test, it'll be like this. You know what I mean? It'll be more like prove it. Or do you remember in the video I did one with an X, and it was like prove it with X, like you plugged in X. It'll be something like that. The biggest thing I can tell you to recognize is cosine. They're the same on one side, and you flip your sign. Sine. So with sine, actually, you can mess up, but sine is what? It's sine, cosine, cosine, sine, and then you keep your sine with sine. You start with sine and end with sine, and you keep your sine in the middle. I don't know. That's all I got. Enjoy. Even chimpanzees can memorize 7 things, guys. So alpha, beta. So you keep the order. Alpha, beta. Technically, if you mix this up and do it in reverse, it'll be the same answer. Just remember, you do sine once with a cosine the other. Like if you do cosine, sine, sine, cosine, you'll get the same answer. What was sine alpha? 4/5. Ooh. Technically, couldn't I do pi minus this and get it? Yeah, you can, because they're complements, but don't do that. What was this, 1/2? Plus Jiminy Crickets, that's not 1/2. You asinine buffoon. It's root 3/2. Cosine alpha was -3/5. And sine of beta was 1/2. So this one I get 4√3/10 minus 3/10. 4√3 minus 3/10. No calculator required. No unit circle required. Because we get all this stuff. We need to draw reference triangles. Whew! All right. 2 more examples, and I can retire. Oh, you guys will love this one. Do y'all realize I think we have like 5 lectures left? Yeah, I think we have. I need those views. I need to get to 500 or I'm not going to stop. I need 1. Who's out there? You got to like and subscribe. Hit that bell notification. I'll find you. I'll find you. I don't know. I should just, what if I release more raps? Ooh. No, monetized. All right. Hey, y'all. Tell me this doesn't look like the most fun you can have in this classroom. What's more fun than this? Who's got better than us? Nobody. Because we're all chargers now. All right. How am I going to do this? I'll give you. All right. How about I'll tell you? They give you a hint. They said, let's do some substitution right here. Because watch this. I'm going to show you how easy this is. Let's go, party. I am actually more depressed than I thought I would be. All right. About it. All right. So what am I going to do? I'm going to substitute in a u and a v. Okay? Do I know what to do if it's sine of u plus v? Is that something I can do with my current tools? Yeah. Now watch this. What? Yeah, we're going to do a u and v. These are my triangles, correct? I made a u and a v. I used my ratios from this, correct? If tan is 1, it means it's 1 over 1 in root 2. If cosine and v is 1 over x, or x over 1, okay?
Yeah.
What? U and v is just common terms for substitution. When you do calc, anytime you substitute, it's a u and a v. It's actually called UV substitution, is what's called when you get to calculus. That's a V. That's a V. U's have tails and V's don't. I'm embarrassed for y'all. All right, so my formula is sine of U times cosine of V, is that better? Plus cosine of U times sine of V. All right, now look at this. I made these triangles using my inverses. This is opposite over adjacent, so I did 1 over 1. If that's a 1 and a 1, that's square root 2. And I made this triangle by doing x over 1 because that's adjacent or hypotenuse. So now with those ratios, I can do this. Watch this. What's sine of u? Sine of u is opposite over hypotenuse. So it is 1 over root 2. Do you guys see that? Based on this triangle. Cosine of v is what? Adjacent or hypotenuse. So it's x over 1. So I took unknowns, I'm going to make them known. Well, not really. You have to have x in your answer because this is an expression. What's cosine of u? A over h, so it's 1 over root 2. And now what's sine of v? Uh-oh, SpaghettiOs. Can I find that missing side? What's x squared plus, what letter do you guys want to use here?
W.
Plus smiley face squared equals 1 squared, right? Do y'all agree on that? So, smiley face squared equals 1 minus x squared, right? How do I unsquare the smiley face? Square root it. So smiley face is square root of 1 minus x squared. So what can I plug in right here? Square root of 1 minus x squared. That's a new one. You will not see this in a calc textbook. I'm going to monetize that. Smiley face variables. All right. So what's sine then? It's opposite over hypotenuse. Right? Did I do it right? I did. Now, what's 1 times x? X. What's 1 times that? That. Smiley face. And what's it all going to be over? Root 2. Do you want me to be honest with you? I've never seen a problem like that either on the AP test yet. I do, but I still got to show you, and you still should practice it. If not for that, this sort of U substitution comes up in calculus. So if you're going to take calculus, you should have seen it before. All right, one more example. This one is not as bad as that one. Do you guys believe me?
No.
Oh. What?
500 subs. Let's go.
Even the computer didn't want to do it. Is it like flickering now? This is fun. Look at those smiley faces. It's the 500 subscriber special. I should bring in treats tomorrow for you guys. Well, I didn't get my Kleenex boxes. I got 4. I've been out of Kleenex. I've been blowing my nose on paper towel. What? All right. Let's use our double angle formulas. This will be slightly different. All right, they tell us something. They say cosine of theta is 3 over 5. So I'm going to draw it over here, right? And it's 3 over 5. Wait, why did I draw over there? What's this? What quadrant is that? 1, 2, 3. It would be over here, right? Y'all dig? So my cosine is going to be positive. What's my sine going to be? Just kind of think about it. Sine's going to be negative, right? Right away, what kind of triangle is this? It's a 3, 4, 5. I'm going to make that -4 because I went down, right? Ay caramba. All right. So they want to know what sine of 2 theta. Mr. Twilliger, we don't know what theta is. How are we supposed to do it? Well, if we look back a few pages, what's our double angle formula? Can I convert this into something? Are these the same thing? Yeah, it's on page 144. Do I know what sine of theta is? Yeah, it's what, -4 over 5? And what's cosine of theta? 3 over 5. And what's 2 times 4 times 3? -24 over 25. See, that one wasn't as bad, right? Maybe. Maybe. I said maybe. You're gonna be the one who saves me. Now, how am I gonna find cosine of 2 theta? No, no. What's my formula for that one? Isn't there 2 involved too? Oh, which one? Which one do you want to? Doesn't matter which one we use. Which one do you guys want to use? I did the 2 cosine squared minus 1, but is it? You guys want to do the cosine squared minus sine squared? All right. Uh-oh. That's on page 144. What's cosine? 3/5. What's sine? -4/5. Yarnar. Oh no. Oh wait, that's a -2, right? Yeah, minus. All right. So what's 3 squared? 9 over 25. Minus what's -4 squared? +16, right? Because we're squaring it. And what's 9 minus 16? There you go. You could have done it any one of the 3 ways and you get the same exact answer. The answer is -725. You didn't even plug in your calculator. Probably not a calculator question. All right. So that's it. Happy 500 subscribers.
Yeah,